Welcome to Armchair Physics. Today we're talking about free fall. What happens when you drop something? You might think that's too trivial a question, but actually it was exactly this question that led Einstein to his breakthrough theory of general relativity that gave us the Big Bang and black holes and all that. So let's talk about free fall. Now first let me tell you what I mean. Free fall is when an object is acted upon only by gravity, or more precisely, when all other forces are negligible. So if I drop this plush eggplant, it just falls. I don't really have to worry about air resistance. Similarly for this toy, those are in free fall when I drop them. On the other hand, this piece of paper is much lighter and much less aerodynamic. The air really pushes up a lot on it, and so it is not in free fall when I drop that. So when I say free fall, I will mean something that is acted upon only by gravity. Now, most household objects that you might drop, like your cell phone or whatever, will be in free fall. So we all have a fair amount of experience with it. But if you haven't taken physics, there's something interesting about it which you might not have noticed, which is that it's universal. It doesn't matter what you drop, it falls in exactly the same way. This stuffed eggplant is a lot lighter and differently shaped from this toy school bus, but we don't have to worry about the air resistance when we drop either of them. They're both in free fall, and they fall at exactly the same speed and hit my lap at exactly the same time. Now, this little fact about free fall was known since the time of Galileo, but it was really Einstein who figured out what it means for physics. And Einstein thought about it in roughly the following way. He imagined somebody falling, someone in free fall, and let's think about Alice at the beginning of Alice in Wonderland, who falls down the rabbit hole. And she falls, and at first it's very exciting, but the fall just keeps going, and eventually she gets, a little bored. And let's imagine she's really in free fall. There's no air resistance or anything, so she's really not feeling much at all. It might be quite boring indeed. So she's falling and falling, she's in free fall. Now here's the question Einstein asked. What happens if Alice takes something out of her pocket, maybe her pocket watch, to check the time? So she takes out her watch and she lets it go. Well, free fall is universal. Doesn't matter whether you're Alice or her pocket watch, you'll fall in exactly the same way. So the watch falls too. So they're falling together. Well, but think about it. They're falling in exactly the same way. So from Alice's point of view, she might say, it's not falling, it's just floating there right next to me. Now, of course, if she can still see the scenery on either side as she's falling around, then she might say, no, we're both falling. But let's take it a step further. Let's put Alice and her pocket watch inside a box, like an elevator car, and have all three of them falling together. Now Alice really has no way to know she's even falling. If she forgot how this whole thing started, she would probably say, I don't know what you're talking about falling. I'm just floating here in this box. Right? The box is moving too, Alice is moving, everything is moving exactly the same way. So they can't tell. Anything Alice does inside will float. She could toss things around. They would just move in a straight line. Everything will float. She's floating. She says, I'm not falling. I'm just floating. And this was Einstein's great insight, which is that you can't tell locally if there's gravity or not. If you're in free fall, you might as well say there's no gravity at all. And that's actually what led Einstein to formulate gravity not as a force, but as the curvature of space-time, which is a bit of a doozy and a topic for another video. But for now, the point is this was a very important realization of Einstein's. So based on this idea, he ended up working out some mathematics, and he got the theory of general relativity, and he had a lot of fun, surely, in his life watching its implications be worked out and its experimental confirmation come in. But one thing he didn't live to see was people actually realizing his thought experiment of falling continuously and having things float next to them. I claim there are people doing that right now. Can you think who they are? Remember what I said about free fall. Free fall means you're only acted on by gravity. Can you think of anyone? Well, recently was some news. Jeff Bezos went to space. Branson, 2 millionaires, became astronauts, right? Astronauts are people who are continuously in free fall. They're acted on only by gravity. All the other forces are negligible. And indeed, when they take stuff out of their pockets, it floats by them. Now, that definitely satisfies the technical definition of free fall I gave, right? Just gravity acting on them. But if you want to understand it a little more viscerally, you can relate it to ordinary notions of falling by just thinking about what it means to orbit the Earth. So an astronaut in a space capsule outside the Earth, let's imagine we just let the space capsule go. It would, of course, fall to Earth, just like Alice falls down the rabbit hole, right? And during that free fall, stuff would float. But what if we gave the astronaut's space capsule just a little bit of speed in this way to start? Then it would fall towards Earth, but it would make an arcing trajectory a little bit. It would curve. Let's orient it this way. Instead of just directly falling, it would also curve a bit and fall. But if you gave it a little more speed, it would curve a little more and fall. And you could adjust the initial speed so the amount it curves is exactly equal to the curvature of the Earth. And then it just goes into a circle. And that's an orbit. That's what astronauts are doing. And that's how it relates to falling. So anyway, next time you see some news about astronauts, or you watch a video of what it's like in space, or maybe you go to space yourself, you can think that you are realizing Einstein's thought experiment that led him to discover the theory of general relativity.